A warm welcome to everyone. I am Kushwan Boyda, DevIncept community lead, and I will be the host for this deep learning session. DevIncept is an open source community which provides free courses to enthusiastic learners and internships. So coming to the speaker, Miss Priyanka Shahane. She is currently working as an assistant professor at Department of Artificial Intelligence and Data Science, AISSMS IOIT Pune. She has 4+ years of experience in different fields like teaching, machine learning, research, HR management, software development, and student counseling. She has published 8 research papers in different national as well as international journals such as IEEE, IJMTE, IRJET, and IRJET. She is certified in artificial intelligence by reputed organizations like IBM, Accenture, TCS, Harvard University, Microsoft, and Udemy. She delivered expert sessions and workshops on machine learning and deep learning at Department of Computer Engineering, Nashik, and Department of Electronics and Telecommunication at IISSMS IoT Pune. A warm welcome, Ms. Priyanka Shahane.
Thank you so much, DevIncept, for the warm introduction.
So you can share your screen and you can start
Yes,
explanation.
is it visible now?
Yeah.
Okay. Good morning, everyone. My topic for today's session is Introduction to Deep Learning. First of all, let me tell you a little bit about myself. My name is Priyanka Shahane and I am currently working as an assistant professor in AI and DS department of AISSMS IIT Pune, and I am having around 4 years of experience in different fields like teaching, machine learning research, software development, student counseling, and HR management. I have published 8 research papers in different national as well as international journals like IEEE, IJMT, IRJT, IJRDT, and JETR. Also, I'm certified in artificial intelligence by reputed organizations like IBM, Accenture, TCS, Harvard University, Microsoft, AICTE, and Udemy. These are the contents. First of all, let us see the relation between artificial intelligence, machine learning, and deep learning. Deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence. Now, let us see what is artificial intelligence. Artificial intelligence is the ability of system to imitate intelligent behavior of humans. Here intelligent behavior refers to how human brain thinks, learns, decides and solves the problems. Let us see one example of artificial intelligence. It would not be possible for a human to note down the numbers of all the cars which exceed speed limit on the road, because number of cars may pass through that road at the same time and millions of cars may pass through that road in a day. So this task is next to impossible for human being. Now let us see one other approach to solve the same problem. In order to solve this problem, we can use machine to capture the picture of number plate of car and convert that text into text format. So here conversion of image to text is done with the help of natural language processing technique of artificial intelligence. And now we can do this task very easily with the help of artificial intelligence. AI has number of applications in different fields. Like in healthcare, artificial intelligence can be used for cancer cell detection or detection of brain tumors. In transport, it can be used in Ola and Uber cars for predicting the optimal paths. In agriculture, it can be used for detection of crop diseases. In education, it can be used for automated spelling and grammar corrections. In e-commerce, it can be used for market basket analysis. Market basket analysis means identifying which items are frequently bought together by customers so that appropriate offers can be given by seller on those items. For example, customer who buys milk also tends to buy bread. So these type of correlations are identified with the help of artificial intelligence. AI can be used in entertainment industry in the form of YouTube or Pandora. Whenever you watch some video on YouTube frequently, you get recommendation for similar kind of videos. So this is done with the help of artificial intelligence. AI is used to design robots which can do the task like humans. In automotive industry, AI used to generate self-driven cars. On social media, AI is used for automated tagging. Whenever you post your picture on Facebook or Insta, you get automated tags for those pictures with the person's name. This is achieved with the help of artificial intelligence. In data security domain, AI is used in the form of fingerprint recognition or iris recognition. In finance industry, it can be used for credit card fraud detection or identification of high credit risk customers. AI is used for playing online games like chess. It is used to decide next move in such games. Robots can be sent to the astronomy, for example, for navigation on Mars or other planets where human beings cannot reach easily. Now, let us see what is machine learning. We have already seen that machine learning is a subset of artificial intelligence. So, machine learning is a set of algorithms that provides the system with ability to learn from given set of examples without being explicitly programmed. Here we have number of algorithms in machine learning like support vector machine, random forest, linear regression, multiple regression, neural networks, etc. So all these algorithms provides the system with ability to learn from given set of examples without being explicitly programmed. Here, without being explicitly programmed means we do not need to hard code our machine for that. Let us see one example of machine learning. Here we have two images. One image is of cat and another image is of dog. Humans have seen many cats and dogs since they are born. Therefore, they can easily identify the difference between two. But if machine wants to do the same task, then how machine will do that? In order to machine to do the same task, first we have to train our machine with number of images of cats and dogs. And after training our machine learning algorithm or our system with such training data, we take an input image for which we want to generate label. Here generating label means identifying which image is of cat and which image is of dog. So we are picking up one random image from this training data set and providing to our machine learning model for prediction. But before providing this image to our machine learning model, first of all, we need to extract the features that are important for classification of given image as a cat or dog. And important features can be height of that animal, color of that animal, presence of whisker, shape of ears, etc. All these features are important in classifying cats and dogs. So we extract all these features manually in case of machine learning and provide those features to our machine learning model. This machine learning model can be any machine learning algorithm like support vector machine, random forest, linear regression, multiple regression, or convolutional neural network. Like this, we can use any algorithm as our machine learning model. And after providing these features to our machine learning model, our trained machine learning model will automatically classify given image as a cat or dog based on the training that algorithm has received previously from the training data. And then in order to check the accuracy, we will compare the label we will compare the generated label with the actual known label for that image. This is how machine learning algorithms or machine learning models work. Machine learning has three main types: supervised learning, unsupervised learning, and reinforcement learning. Now let us see what is supervised learning. In case of supervised learning, we have class level data present in the beginning. Class level data means, let me give you one example. If you have images of cats and dogs and you have labeled which image is of cat and which image is of dog, then such data is known as label data. So in case of supervised learning, we have class level data present in the beginning. So we divide that label data into two parts: training data and testing data. Generally, we keep training is to testing ratio as 70 to 30 or 80 to 20 in our machine learning models. So with the help of training data, first of all, we train our algorithm. As I told you, this algorithm can be any machine learning algorithm like SVM, RF, LR, KNN, etc. So after training our algorithm, we have to check accuracy of our machine learning model that is generated after training the data, training the model. So in order to check the accuracy, we make use of that 20% or 30% test data, and accuracy is checked with the help of different performance metrics like precision, recall, F1 score, etc. We will see about all the performance metrics in detail in our next slide. Now let us see what is unsupervised learning. In case of unsupervised learning, we do not have class level data present in the beginning. So we group our data based on two parameters, and those two parameters are high intra-class similarity. Here high intra-class similarity means elements within one class are highly similar with each other. For example, we can say elements of class 1 are highly similar among each other, and elements of class 2 are highly similar among each other. And second is low interclass similarity. Low interclass similarity means elements of class 1 will have less similarity with elements of class 2. This is how we group the data in case of unsupervised learning. Now next type is reinforcement learning. In case of reinforcement learning, agent learns from its past experiences and current actions. In this figure, here you can see we have one agent, and this is an environment for this agent. So in this environment, agent has two choices. First choice is either to touch the fire and or to touch the water. So first of all, agent will touch the fire, and after touching the fire, he will get some burning sensation, or we can say penalty. So after touching the fire, agent has learned that he should never touch the fire ever again. So agent will update this policy. Now agent has only one choice remaining, that is to touch the water. So after touching water, agent will come to know that he is not getting any burning sensation, so he can touch the water again. So here optimal policy is touching water. So agent will iterate till optimal policy is found. Here agent has learned from his past experiences and current actions, therefore it is known as reinforcement learning. Now let us see what are the limitations of machine learning. First limitation of machine learning is machine learning models cannot deal with very high dimensional data like data in terabytes or data in gigabytes. And second limitation is since machine learning models cannot automatically select the features, it becomes difficult to solve complex problems like fingerprint recognition or image recognition. If you remember, in the machine learning example, we have extracted features manually. In case of cat and dog image classification, we had extracted features like height of animal, color of animal, presence of whiskers, shape of ears manually. And after extracting these features manually, we have provided these features to a machine learning model. But if we want to solve the complex problems like fingerprint recognition or iris recognition or image recognition, then it is difficult to extract all the features manually, because you all know fingerprint has number of patterns and it is not possible to extract all such features manually for human being. So these two are the main limitations of machine learning. So these limitations can be overcome by another technique, that is deep learning. Now let us see what is deep learning. Deep learning uses multi-layered neural networks capable of identifying important features by themselves. In case of machine learning model, we used to extract the features manually, but deep learning models can automatically extract the important features by themselves, and they can learn from large amount of data to solve the complex problems like fingerprint recognition, iris recognition, or face detection. Here we can see both the limitations of machine learning models can be overcome. This is an example of deep learning model. If you want to label given image as a cat or dog, then we will take an input image and we will directly provide this input image to our deep learning model. Here we are not extracting any feature from given image. We are directly providing this image to our deep learning model. And our deep learning model can automatically classify the given image as a cat or dog based on the training that deep learning model has received previously. This is another example for comparison of machine learning and deep learning. Here we have to identify whether the given image is of car or not car. So let us see the first approach to solve this problem. Here we are using machine learning technique. In case of machine learning, first of all we have to take input image and extract all the features that are necessary for classification of given image as a car or no car. And in this case important features can be number of wheels, height of vehicle, shape of vehicle, etc. So in case of machine learning, we have to extract all these features manually and provide those features to our machine learning model. In this example, machine learning model used is simple neural network, because we can see here this neural network has only one hidden layer. So this is a simple neural network which is not a deep learning model, which is machine learning model. And this machine learning model will classify given image as a car or not car based on manually provided features. And if we want to solve same problem using deep learning, then we can directly provide this image to our deep learning model without extracting any feature manually from given image. So here efforts of human have been reduced, and our deep learning model can automatically extract the important features required for classification and classify the given image as a car or no car. This is the difference between machine learning and deep learning models. Deep learning models make use of neural networks having more than two hidden layers. And these neural networks are inspired by biological neuron. Biological neuron means our brain cell. Let us compare the artificial neuron and biological neuron. This is the figure of biological neuron, and it has dendrites. These dendrites perform the task of receiving signals from other neurons, and dendrites are analogous to this input layer in artificial neuron. Here x1, x2, x3 and xn are the input signals. Then in case of biological neuron, cell body is there which sums up all the inputs. This cell body is analogous to transfer function in artificial neuron. In case of artificial neuron, at the place of this transfer function, we sum up all the input and weight pairs like x1 into w1 plus x2 into w2 plus x3 into w3 plus xn into wn. And at the place of activation function, we keep some threshold to divide our data into two classes. For example, we can put threshold value like 50, and all the values below 50 will go to class 1 and all the values above 50 will go to class 2. This is how we can do the classification with the help of activation function. And this activation function is analogous to axon in biological neuron. If this signal exceeds some threshold or exceeds some distance, then only it can travel to next neuron. There are a number of types of activation functions. First one is linear function, and it has equation f of x equal to x. Here x is nothing but our input signal, and it gives output in the range of minus infinity to plus infinity. It means we can do multi-class classification with the help of linear activation function. Next one is step activation function. If value of input signal, that is x, is less than 0, then it will send the values to class 1. And if value of input signal is greater than or equal to 0, then it will be classified as another class, that is class 1. And it gives output in the range of 0 to 1. Next one is sigmoid activation function, and it has formula 1 upon 1 plus e raised to minus x. Here x is nothing but the input signal, and it gives output in the range of 0 to 1. Next is hyperbolic tangent function. It is also known as tan h function, and it has formula e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. Here x is nothing but the input signal, and it gives output in the range of minus 1 to 1. Next is ReLU. ReLU stands for rectified linear unit, and it gives output in the range of 0 to infinity. Leaky ReLU has formula when x is less than 0, it will give output 0.01, and when x is greater than or equal to 0, it will give output equal to x, and it has range minus infinity to infinity. Next is switch activation function, and this is the formula for switch activation function, and it will give the output in the range of minus infinity to plus infinity. This is an architecture of deep neural network that we use in case of deep learning. We can say given neural network is deep when there are more than two hidden layers. You can see in this figure, this first layer is known as input layer, this last layer is known as output layer, and the layers between input and output layer are known as hidden layers. So When there are more than two hidden layers at that time, we can say given neural network is deep neural network. And in case of deep neural network, at each layer we go into more and more deep in order to predict our output. Let me show you one example of deep neural network. Here in this example, we have to perform the task of face recognition. So at first layer, we will extract the patterns of local contrast like luminosity, brightness, etc. In next layer, we will extract the face features like nose, ears, eyes, etc. And at next layer, we will identify the actual face. So here at each layer, we are going into more and more deep in order to predict our output. Now let us see the difference between machine learning and deep learning. In case of machine learning, we have to extract or choose features manually, but in case of deep learning, we do not need to extract or choose features manually. In case of machine learning, size of training data set is small, but in case of deep learning, size of training data set is large. Time required for training is short for machine learning as the dataset size is also small. But in case of deep learning, we may require very long time for training. In case of machine learning, we do not need high-end system, but in case of deep learning, we need high-end system. Machine learning has many algorithms like support vector machine, random forest, linear regression, multiple regression, KNN, etc. But deep learning has very few algorithms like deep convolutional neural networks, LSTMs, etc. Let me show you one real time example. This is a project where I have identified whether the given profile is fake or real. So, in order to do these tasks, first of all, I have extracted the accounts from one social media platform, and platform is Twitter. So data acquisition is done with the help of Twitter API. And next step in any machine learning algorithm is pre-processing. Pre-processing means removing the redundant or duplicate data and cleaning our data for further processing by algorithm. So in pre-processing, here I have performed number of steps like lexical analysis, top word removal, steaming, index term selection, and data cleaning. In lexical analysis, we identify the spaces, new line characters, commas, etc. In stop word removal, we remove most frequently occurring words like of, and, the, uh, which are not much important for predicting our final output. In steaming, we identify multiple forms of the same word and map those multiple forms to one word. For example, do, doing, done can be mapped to only one word, that is do. In case of index term selection, we identify the important features that are required for classification. In this project, we wanted to classify the given profiles as fake or real. So for that classification, important parameters are username, screen name, account created date, profile image, friend counts, followers count, location, listed count, and account age. Because if username is something like 111 or 000 or XYZ, then it may happen that given account is fake. Or if account created date is too of long back, then it may also happen that account is fake. If friend counts and followers count is very less, then account tends to be fake. Also if location is giving of some volcano or ocean, then also account tends to be fake. So all these parameters are identified to be important for classification of given accounts as fake or real. Also, if we do not have many fake accounts with us, then we can manually create such accounts to train our machine learning model. So here we have manually created some fake accounts or fictitious accounts, and we have cross checked the fictitious accounts by making use of two tests, that is man Whitney U test and chi-square test. These tests analyze the difference between fictitious accounts and real accounts parameters. Then we inject such fictitious accounts to our machine learning model for training our model. Also, we create some new features like friends to followers ratio feature can be created from existing features, and these features are found to be important for classification of fake versus real identities. Here I have used random forest algorithm of machine learning for classification of given profiles as fake or real. And also I have experimented with number of cross validation techniques like 4-fold, 5-fold, 10-fold, 12-fold and 15-fold. Results are evaluated with the help of number of performance metrics like precision, recall, f1 square, specificity, etc. Now let us see how same problem can be solved with the help of deep convolutional neural network or deep learning. Here, instead of random forest, I just use deep convolutional neural network, and I have experimented with number of activation functions of deep neural network, that is linear, sigmoid, tanh. Also, I have experimented with different cross validation techniques, and here I found that sigmoid activation function is giving highest classification accuracy for this particular problem. And I also found that as number of folds are increasing, classification accuracy is also increasing. These are the accuracy values, and I found that sigmoid activation function with 15-fold cross validation technique is giving highest accuracy of 95.10% for this problem statement. Now let us see how we can calculate the accuracy. Accuracy is calculated using this formula, TP plus TN upon TP plus TN plus FP plus FN. Here TP stands for true positive, TN stands for true negative, FP stands for false positive and FN stands for false negative. Here true positive means when the actual value of output is positive and predicted value is also positive, then we can say it is true positive. False negative means when the actual output class is positive and the predicted output class is negative, then it is false negative. When actual class is negative and predicted class is positive, then it is false positive. And when actual class is negative and class predicted by our classifier is negative, then we can say it is true negative. Similarly, we can calculate precision, recall, F1 score and specificities using TP, TN, FP and FN. If anybody has any doubts, then you can ask me.
Priyanka, there are some few questions from people. So Ajay is asking that in what format data is fetched from Twitter and what will its format after pre-processing?
Yes. So we can either directly get the .csv file from our API, or we have to process it in and convert it into a required format. Like .csv file is generally used for processing in Python. So we have to convert the data into a given format.
Okay. Hope Ajay got his answer. And another guy is asking, what are the career opportunities in machine learning and deep learning? How to go on?
Yes, yes. In case of machine learning, you will get different positions like machine learning researcher, machine learning engineer, data scientist, data analyst. In case of data analyst, you have to focus on different tools like TableView, Power BI.
Okay.
For data science is more focused on data pre-processing. Machine learning engineer more focuses more on algorithms like random forest, deep convolutional neural networks, support vector machine, KNN, etc. Machine learning researcher tries to improve the accuracy of given problem statement by referring the research papers. So these are the different opportunities in the domain of machine learning.
And one more question is that what is the prerequisite to learn deep learning or machine learning?
In order to learn deep learning, first you have to learn neural networks. And
Okay.
for learning machine learning, means you can learn Python programming language and different machine learning algorithms.
Okay, nice. These are some questions. You can continue this session.
Okay, now let me tell you a little bit about DevIncept. Mr. Arpit Dwivedi is a founder and CEO of DevIncept. Omkar Shinde is the head of community operations, and Mr. Abhishek Patel is the operations manager over here. DevIncept is an open source organization started by developers for developers, and it is founded in August 2020 with a mission to take technical education free to all the students. DevIncept believe in project-based learning approach, which is one of the best techniques to learn a new technical skill. DevIncept offer one of the best technical training programs in the market for free. At DevIncept, it's all about open source. So you do not need to pay for any service over here. Now let us see what are the various problems faced by student developers. First problem is no group-based development. Second is no real-time development on GitHub repository. And third main problem is growing technically without mentor. So these are the most prominent problems faced by student developers. And DevIncept provides solution to all these problems. DevIncept provides you group-based learning platform, and it also provides you real-time development on GitHub and allows you to grow yourself with a technical mentor. You can enroll for a free certification courses provided by DevIncept. DevIncept has courses on Python, machine learning, natural language processing, OpenCV, deep learning, data structure algorithms, web development, and Android development. You can also participate, compete, and upgrade yourself. Different kinds of competitions organized over here are blog competitions, online webinars, and contribution programs. Interactive learning is also a part of DevIncept training curriculums. Now, let me tell you why to choose DevIncept. First of all, you will learn in-demand skill by implementing for free. Second is compete with other participants in weekly project-based assignments. So you will find people just like you to compete with them, and you can work on different project assignments. And you can also show your skills and get chance to intern with DevIncept. This is our DevIncept community. You can follow DevIncept on YouTube, Telegram, and Instagram using given links. Thank you, everyone. If anybody has any queries, then you can ask.
Yeah, there is one more query is that true and false values from API are out of algorithm, right?
Yes.
Question is asked by Ajay.
Yes, so we need to encode such values using technique one hot encoding. So true value can be converted to 0 and false value can be converted to 1 using one hot encoding technique of machine learning. And our machine learning algorithm can process such encoded values.
And I have circulated the Google form for the certificate in the comments, and whoever fill that, they will get the certificate by end of the day.
Okay, Shwa.
So,
All the participants are requested to fill out the form shared by
yeah.
Abhishek.
So, uh, thank you, Priyanka, for the great session. And I expect people got to know some new information and added some more points in the portfolio. So, it's a great interaction with you for the Devincept.
Yes, thank you so much.
Okay. So, I'm ending the live. Is there anything else?
No, not from
Yeah.
my side.